Hey, boys and girls, welcome to Mrs. Walker's sixth grade virtual science class. And the standard that we're going to focus on today is from Life Science. It states analyze cause and effects relationships to explore how changes in the physical environment can lead to population changes within an ecosystem. So let's first talk about the populations of ecosystems, and we refer to that as carrying capacity. The largest population that can be supported by an area's is an area's carrying capacity. An area has different carrying capacities for different populations. When a population becomes too large, some of its members must move or they will die from a lack of resources. The spread of organisms from one area to another is called dispersal. All right, so we're going to discuss first what a limiting factor is and then some examples of limiting factors. When living conditions in an area are good, a population will generally grow, but eventually some environmental factors will cause the population to stop growing. A limiting factor is an environmental factor that causes a population to decrease. Some limiting factors for populations are food and water, space, and weather conditions. So these are situations that occur in particular environments that will have a direct impact on the population of a particular organism or even several organisms. And this can be effects on plants or animals. So the first limiting factor we're going to discuss is food and water. Organisms require food and water to survive. Since there isn't always an endless amount of food and water, they are limiting factors. Suppose a bear must eat 10 fish a day to survive. The river nearby provides about 100 fish a day without harming the fish population. 5 bears could easily live in this area because they would only need 50 fish total. But if there were 15 bears, they would not all survive because there would not be enough food. No matter how much shelter and water there was, the population would not get larger than 10 bears for an extended period of time. So the next limiting factor we're going to talk about is space. Space is another limiting factor for populations. Seagulls, for example, come to nest on rocky shores, but the nesting shores get very crowded. If a pair does not find room to nest, they will not be able to add any offspring to the seagull population. So nesting space on the shore is a limiting factor for seagulls. If there were more nesting space, more seagulls would be able to nest and the population would increase. Space is also a limiting factor for plants. The amount of space in which a plant grows determines whether the plant can get the sunlight, water, and soil nutrients it needs. For example, many small plants sprout each year in a forest, but as they grow, the roots of those plants that are too close together run out of space, and some of the plants will die. Branches from other trees may block the sunlight that small plants need. Some of the small plants might die, limiting the size of that plant population. Weather conditions. Weather conditions such as temperature and the amount of rainfall can also limit population growth. A cold front that comes in late spring can kill the offspring of many species of organisms, including plants, birds, and mammals. A hurricane or a flood can wash away nests and burrows. Such unusual events can have long-lasting effects on population size. That's going to lead us right into our next one, the limiting factor of natural disasters. In an ecosystem, the population of a species will increase until it reaches the carrying capacity. Then the population size remains relatively the same. If an abiotic or abiotic factor changes, the carrying capacity changes as well. Natural disasters can destroy resources in an ecosystem. If resources are destroyed, the ecosystem will not be able to support a large population. This causes the carrying capacity to decrease. Humans can also alter the carrying capacity. Our activities can decrease or increase the carrying capacity. We alter carrying capacity when we manipulate resources in a natural environment. And I believe that one of the greatest impacts that we have is our use of land and space. We tear down natural habitats to build homes or neighborhoods or schools or shopping areas. But what we don't take into great consideration is what do we do when those spaces are vacant and we don't return them back to the natural resources that it once was. And I think that that's something we could really focus on and make some changes, even in our environments, in our neighborhoods, as far as cleaning up and returning things back to natural that are things that are no longer being useful or used. So we, as humans, we have a huge impact on the carrying capacity and resources within our natural environment. I have a couple of examples I'm going to show you next. So here's an example of a wolf and moose population, and you can see on the y-axis here we have the number of wolves. It goes from 0 to 60, and on the x-axis here we have the year span from 1955 to 1995, and then you'll see also over here another y-axis that we have the number of moose. And so you've got to look at our key here because we've got two different lines on this graph, two different pieces of data that are being plotted. We have the wolves and the moose. The wolves are the dotted lines, the moose is the solid lines, and you can see that their populations are directly related. When the wolf population was kind of increasing, you'll notice the moose population then took a dip. But as the moose population took a dip, so did the wolf population. So you can kind of see that they're in proportion here. The moose population starts to increase, and we're going to notice the wolf population is going to also then begin to increase. But as those wolves increase, you're going to notice the moose decrease, and that's because those wolves are hunting those moose. Then there's a little bit of balance here. I'm sure there are some environmental factors that are influencing their relationship as well. And then again, you see similar here as the moose population, it kind of takes a little dip here and then it starts to rise again. It rises because the wolf population has decreased. So the fewer the wolves, the more moose. Now, the more moose we have, the more wolves we have, we're going to notice here that the moose population is going to begin to take a dip. So they are related to one another, how one animal affects the other, and that's based on the carrying capacity in that environment, whatever factors are affecting whatever limiting factors are affecting the habitats for both the wolves and for the moose. And you can see how those two organisms are directly related to one another. So here's another one, and this one is very interesting because it's talking about the population growth of reindeer, and this took place in the tundra, and this was a very long time ago, but in the tundra where both the reindeer and the wolves live, the number of reindeer herds do not exceed the carrying capacity of their environment. In 1944, the United States Coast Guard transported 29 reindeer to St. Matthew Island in the Bering Strait. St. Matthew Island has a typical climate for a tundra, but no wolves live there. So you can see how they introduced 29 reindeer in 1944, and there was no predators and nothing probably to really affect the environment as far as limiting factors go for these reindeer, mainly because there were no predators. And so we had this crazy population growth from 29 reindeer to over 6,000 in a very short time period here, 20 years. And then this huge drop, this massive decline. It said 42 reindeer left, and they were probably had to go in and create a hunting season, or an environmental factor that may have happened could have been that they had really exceeded the plant life that was there, which meant that they weren't able to get enough food. There weren't enough resources on the St. Matthew Island for this large, massive population that increased so quickly. So we lost the reindeer population took a huge decrease because they ran out of a needed resource of, I'm guessing, food. All right, that is it for our lesson today. Thank you for joining.